Hello, this is Mahandra Didia. In this portion of the book on liquid formulation, we continue to cover suspension formulation using integrated approach. This is a follow-up to the earlier module 9 on pre-formulation, where laboratory results of solid properties were discussed. In this particular module, we will look at formulation and composition. The formulation and composition contains three related videos: submodule on vehicle and surfactant, auxiliary agents, and formulation composition. In this diagram, drug suspension particle is shown. It could be solid or a lipid, insoluble in the vehicle. Small amount of particle may be soluble. Substantial portion of the particle remains insoluble. It is supersaturated solution with respect to the particle. Surfactants, polymers are also used to stabilize suspension. In formulation composition, we would look at pharmaceutical composition, including COVID vaccine, Pfizer and Moderna, lipid nanoparticles in a suspension formulation. Suspension vehicles. Suspension is a biphasic dispersion of insoluble solid in general or lipids in vehicle to create a stable suspension. So in order to create stable suspension, we need to provide energy to disperse solids into vehicle and create uniform distribution of solid throughout the vehicle. That means suspended particles must be uniformly distributed, and that requires mechanical energy or acoustic energy or different types of energies. Vehicle composition with ingredient controls the characteristics of suspension. Vehicle attributes are insoluble solids or lipid particles that are suspended. Vehicle contains soluble ingredients also to stabilize suspended particles. For example, in oral suspension, palatability and preservatives are required. Vehicle attributes include physicochemical properties of suspension. For example, many oral pharmaceutical suspensions are flocculated and they need to be redispersible. They can be deflocculated, such as many of the cosmetic suspensions are. Vehicles provide physical, chemical, and microbial stabilities. Energy required to form suspension, either vehicle attributes are there, and then mixing or other energy can be provided. Mechanical energies are then to disperse solid evenly through continuous phase. Readers are requested to refer to Module 6.1 for solution and suspension and 14.2 for suspenoid in emulsion vehicle. Suspension composition involves insoluble particles separated from the adjacent particles. That requires carefully selected vehicle properties. In this module, we will focus on composition of vehicle. Suspension contains insoluble and soluble materials, so specific solid particles are insoluble. It contains wetting agents, suspending agents, flocculating agents, pH and buffering agent, preservative, antioxidant, and organoleptic agents, taste, color, and fragrance. It will depend on the product. For example, orals will require many of these, whereas parenteral formulation requires some of these. That will depend on the formulation and composition of the product. Mechanical energy is required for suspending it. In this particular video, we will see that if we provide mechanical energy, particles will be suspended, provide sufficient mechanical energy. So let's look at the video. So we start mixing, and for example here, the red particles are shown. As the mixer starts, you start seeing particles move and start suspending. However, you will see clear liquid on the top. That means there is not enough energy provided to suspend the particle. Both views show, however, in this view, as we increase mixing energy sufficiently, suspension will be uniform, as it can be seen here. So we need to provide sufficient mechanical energy. Since both soluble and insoluble ingredients are there, continuous medium in suspension, which is vehicle, contains drugs, pigments, micas as insoluble in the vehicle. Other materials such as electrolyte, preservatives, etc. are soluble. Common example of vehicles are water for oral suspension, alcohol, glycerin, polyethylene glycol, and propylene glycols are also used, but they have to be used very selectively so that the material that needs to be suspended continues to be suspended, not dissolve in the co-solvent or the solvent. Here's an example of naproxen sodium suspension. After shaking it, it looks uniform. Solubility and insolubility of the material which are used as an act is affected by the pH. And this particular property is used to make suspension. Many suspenoids or solutes are either weak acid or weak bases. And solubility of ionic compounds depend on pH according to Henderson-Hasselbalch equation. Acidic solutes are less soluble in acid. Basic solutes are less soluble in basic vehicle. So this property can be used. The pH of the suspension whereby the solute is essentially insoluble in that. And we will look at the examples in formulation composition. Surfactants are used as wetting agent and dispersant. So surfactants are commonly used to help separate each particle from adjacent particles and homogeneously distribute particles. It does by several mechanisms, wetting or hydration. Wetting agents are surfactant. They displace air from the particles, reduce the surface tension of aqueous medium from air and water, partially coat the surface of the particle, and it provides protection of a labile active. Hydration or wetting of insoluble materials and polymers used in suspension is one of the first steps in manufacturing process. Agglomeration of particles is shown here in green. It needs to be suspended in liquid, form uniform suspension. The particles can be separated by providing mechanical energy, as you saw in the video. However, these particles will then settle back very rapidly. The particles need to be stabilized, and surfactants help disperse the particles and provide the barrier. So surfactants are important in suspension formulation.